Hello everyone and welcome to our revision lesson on the electromagnetic spectrum. So there is an optional fill in the gap sheet that you can do as you go along which matches with this video, but if you don't want to you can just watch the video, that's absolutely fine. So first definition is what is an electromagnetic wave? It's an oscillating electric and magnetic field. Now they are transverse waves, so these fields oscillate at right angles to each other, and hopefully you can see that in that diagram. So that red field going up and down there is the electric field, and then the magnetic field is going side to side. They are also going at right angles, both of them, to the direction that the energy is being transferred. So three things they all have in common. They can all travel in a vacuum. They all travel at 3 × 10⁸ meters per second. And again, that is a number that you are expected to know. So sound, if you remember, was 340 meters per second. And, electromagnetic waves, 3 × 10⁸. They are also all transverse. So how do we create radio waves? Now this also goes for all the other types of electromagnetic waves, but I'm focusing on radio waves as an example. Apply an alternating potential difference across a wire. This causes the electrons to move back and forward. Now what I mean by that is if you make one end of a wire positive and the other negative, the electrons are going to be attracted to the positive end. Then if you swap over which side is positive and which side is negative, the electrons will go back on themselves, now being attracted to the other end, and so on and so forth. This produces, number 3, a changing electric and magnetic field. This changing field is emitted as a radio wave. Vice versa, if you go back and you try and detect radio waves, so that was making radio waves, now I want to pick them up. If I take a piece of metal, like an antenna for example, and a radio wave is picked up by that piece of metal, it causes the electrons in the metal to move backwards and forwards, which produces an electrical signal. So to make a radio wave, you take an electrical signal and you turn it into radio waves, but the other way around, you take radio waves and you turn them into an electrical signal. So I'm sure you know this already, but the order of the electromagnetic spectrum goes radio waves, microwaves, infrared, visible, ultraviolet, X-ray, gamma wave. Now that order is from the longest wavelength to the shortest wavelength. A really common mistake people make in exams is that they just assume it always goes in that order. I have seen questions where they switched it and they've gone from the shortest wavelength to the longest, meaning they started at gamma and worked their way that way. So that's really common. Please make sure you are looking out for it. Now you are not expected to know the different lengths of the different waves, but you are expected to know that radio wave has the longest wavelength, gamma wave has the shortest wavelength. Radio wave has the lowest frequency, gamma wave has the highest frequency. Radio wave has the lowest amount of energy and gamma waves have the highest amount of energy. They all travel at the same speed, so nothing really changes there. So, uses and dangers. Radio waves, TV and radio, really useful. Don't really have any dangers, they don't carry much energy. Microwaves, mobile phones, Wi-Fi, Bluetooth, satellite communication, heating food. Dangers. You can occasionally heat up body tissue, so that is one of the main things that people do worry about. It's not massive, please don't panic about it too much. Infrared, remote controls is the biggest one. Optical fibre, so if you've ever heard of fibre optic broadband, that's that. Cooking food, dangers, burns perhaps. Visible light, Morse code, lasers and CDs and DVDs and Blu-rays. Dangers, blindness, hence don't stare at the sun, you might get blind. Ultraviolet, uses, sterilising water, producing vitamin D, detecting forward banknotes. Dangers, skin cancer or sunburn, so quite big ones there. You can see they're getting more energetic and the dangers are getting bigger. X-rays, uses, kill skin cancer and detect broken bones, I should probably put that on. Dangers, cancer, not a great one, so that's why they really limit your exposure to X-rays. Gamma rays, again, they kill cancer cells, they sterilise food, very useful, and you can obviously use them in gamma knives and gamma cameras. But again, their danger is cancer, so not great. So, oh dear, that's meant to say imaging, not imagine. Dear, hang on. Imaging, there we go. Oh, that's not how you spell imaging, goodness me. Imaging. There you go, right, we got that. We use 3 types of electromagnetic rays to view inside the human body: infrared, X-rays and gamma rays. Infrared can be used for arthritis or looking at blood vessels and thyroid glands. And you use a thermal camera to produce a thermogram. X-rays, there are two types. You've got the old type of X-ray and the new type of X-ray. The X-rays always go through soft tissue but are absorbed by bone. In an old X-ray, you have a photographic plate which turns black when it's exposed to X-rays. So in the top image, you can see an old-fashioned X-ray. It was originally white, then wherever it's been exposed to the X-rays, it's gone black. And the newer one, which has got, rather than a photographic plate, it's got what's called a CCD, a charge-coupled device underneath. It produces a digital image. And you can see a lot more contrast there of the different densities of bone. CT scans are also X-rays, but they give a more detailed image. It goes, basically that scanner goes round and round and round your body in a spiral shape and makes slices, and then it puts it together to form a 3D image. Gamma is our last form of electromagnetic waves that we look at your body with, and you basically inject a person with a radioactive source. That is then detected going round the body by the gamma camera. So, just a quick note about colours, because this does also fit into the electromagnetic spectrum bit. Roy G. Biv or Richard of York gave battle in vain. So do remember those. So we're getting to the end here. Using colour. Now, you all know that white light is made up of all the different colours. Now, you need to know how we split it up. And it's something called dispersion. This is a bit wonky, let me just move this over. So dispersion is when white light splits up into different colours due to refraction. When light enters a prism, it slows down and refracts. The shorter the wavelength, the more slowly the light travels through a material, so the more it bends towards the normal. This means that violet bends more than red. It has a shorter wavelength, so slows down more. When the light leaves the prism, it is refracted again, and you can see all the separate colours. Last bit, filters. A filter will absorb all colours of light apart from the colour of the filter. White light, you can see at the bottom there, is made up of 7 colours of the rainbow. You've got a blue filter, so all the colours are absorbed except for the blue, which is able to get through. Different surfaces do something very similar, but instead of letting colours through, they reflect them. So here we've got a red surface with all the different colours of light being shone on it. All the colours are absorbed except for red, which is reflected into your eye. And that's it. That's the whole of the topic. So there is a test to do, and I'll see you on Zoom later. Bye.